Okay, so in this question, we have something called singing rod. So this is basically an aluminum rod, and we're holding the rod at the midpoint, and then we're trying to stroke it with the other hand, and then we'll see that some loud, clear sound is coming out of it. So the question is, what's the fundamental frequency of the sound? So fundamental frequency is the frequency which is basically a wavelength, which is basically the initial wavelength or the first wavelength, uh, or the fundamental wavelength that is related to fundamental frequency. And to get the fundamental frequency, we have to see what's the initial wavelength or what's the basic wavelength that we can get. Um, so since we have a midpoint over this region, so that means we'll have a node here, and at least what we can get is an antinode on both sides. So two antinodes on both sides, and because it's a standing wave, as we said. And if we look at a full wavelength, so it looks something like this. And what we're doing is we're taking half of it, and as we see that this part resembles, sorry, so yeah, this part resembles half of the wavelength, and this is exactly what we are getting over here. And okay, so now we know that the wavelength that we are seeing or generated here is a half wavelength. Now the question is, what's the fundamental frequency? So as we know, frequency is velocity over lambda. Lambda is the wavelength, and so velocity, we can, if we use table 2.1, 12.1, sorry, that tells us the velocity of aluminum. That tells us the velocity of aluminum is 5,100 meters per second, and 5,100 meters per second. And then for lambda, what we need to do is we need to understand how to get the wavelength. So you see, this is half of the wavelength, and we know that it's a 80 centimeter rod. So to get the full wavelength, we need to multiply that 80 centimeter by 2. So we'll have something like this, where L is 80 centimeters. So if we need to be consistent with the unit on top, we need this in meters. So 2 times L gives us 160 centimeter, and if we convert that to meters, we get 1.6 meters, and that gives us 3187.5 hertz. Right. So that's the frequency, fundamental frequency of the sound. Now, what is the wavelength of the rod? So we already discussed it here. So twice the length of the rod. So we have 80 centimeters times 2, and we're multiplying, and we're changing our units from centimeters to meters, and that's why we're getting 1.6 meters. Now, the third question is, what is the traveling wavelength of the sound in air at 20 centigrade? Now, the known thing that we have is the frequency, which we derived in first part, which is 3187.5 hertz. And from 12.1 table again, we get the speed of sound in air as 343 meters per second. Now, if we again use the same equation, lambda equals v over f. So we get this equation from here. Here we have frequency equals velocity over lambda. So all we're doing is we're taking lambda here on the left side and putting this frequency on the right side, and we're getting this equation. Right. So now we have all the known quantities. If we plug in all the numbers and solve for it, right, and hertz is basically 1 over second or second inverse. So we get rid of these units, and all we are left is meters. So we have 0.1076 meters, and which is kind of equal to 0.11. So that's the wavelength of sound in air. Thank you.